I'm very glad to be here. Very briefly about me, I'm a data scientist at Unacast, working with location data, aggregating location data to get additional insights in a privacy-friendly way. But before I joined Unacast, I worked for a long time in academia, actually. So I started as a sports scientist, then transitioned to neuroscience, worked for quite some time in motor learning and about consciousness. And now I'm very glad at Unacast to use those skills for other data and other metrics. So that is really cool. And today I want to use the time to talk a bit about what we are doing at Unacast and how that actually can help the retail industry. And also what additional behavioral insights can be derived from location data, which might not be possible with other metrics or other data sources. So Unacast is a location data company, and we have a very clear vision, and that is that we want to understand how people behave and move in the real world, so in the physical world. There are a lot of products out there which do similar things in the virtual world, like social media and so on, but we really want to understand, since we're all living in the physical world, what is happening in the physical world, because we believe that this will help improve products. And especially it will help to give data-driven decisions. So simply put, we are trying to create the real world graph. And of course, you need data to do that. So the data we use is data from mobile devices. So it's basically raw data from mobile devices, and we clean and pre-process that data. We aggregate it to build products on top of that. And this slide is very simple, and a lot of things are happening in BigQuery, but actually behind that there's way more, and it's quite complicated. But that's basically the most important thing, what we need to do to actually have those products ready for the real world graph. And so what is the real world graph? It is you could say it's a combination of a product, a metric, and a location. And that's quite abstract. So I personally like to have it more in a practical sense. So what that means is you have a given location, like a venue on Broadway, and you're interested in, for a given day, what or a given time period, what are the other venues, people who are visiting that store, what are the other venues they're actually going to, and what is the share? So how much percentage goes to the store over here? How much goes here? Something like competitive cross-visitation. But that's just one example. There are many more metrics and different products to actually do. And that's just one example for the real-world graph. So you might wonder how that can actually help the location data and the retail industry. So there are a lot of different questions you have to ask or you need answers for when you work in retail. So just two examples are very common is site selection or competitiveness. So basically, where should I locate my store? If I locate it there, what is happening? Is there a lot of competition? Is this competition actually good? Would it help me? Would it enhance? Or is it just like a weird forest over here? It is, and there are a lot of metrics available to help you understand that. For instance, cash flow based on credit card companies, for instance, or other sources. Demography, census, or different ways, surrounding points. Every company has their own internal data sources. So just based on those metrics, you might say, there's no location data needed for that, right? I can do everything without location data. Wrong. So here I really want to make a point, because location data provides additional insights none of the other metrics actually can provide. And to bring this a little bit more into the intention, it's easier to go with an example. So we just picked a brand here for this presentation, and I was interested in Walgreens, and there are no strings attached. So it's just a nice example to look into Walgreens, because it has a lot of stores in the US. It's the second largest pharmacy in the US, and it has a wide range of products, from pharmacy over healthcare to photography. There's a lot of products offering. So it's interesting to look into Walgreens. How could we help Walgreens with location data? So basically, we can start and looking at one venue of Walgreens. So that's a venue of Walgreens, and they have a whole, not the whole, but a big part of this building over here. There's a UPS store and an ATM on the side, but they have really a big part of this of that area. And now we look into mobile devices we see on a given day in that building or very close to it. And we could now assume that some of those are actually paying customers, so the red dots over here. And those are the ones you have in your statistics. Those are the ones you come with the other metrics. But there are way more other dots here, and there are way more devices seen in the area. And those are potential customers. Those are people who have time and who have opportunity, but they have no motive right now, at least. So location data gives the potential value of a store. Not maybe the paying customer today, but maybe the paying customer tomorrow. So why is this important? If you look over time, it could happen that, for instance, this is the first situation you see for a given venue where you have a high cash flow and a high potential. But then the pandemic happened. And it could actually be that the cash flow over here stays the same amount of those red dots, but suddenly the potential goes low. You wouldn't recognize that without location data. So this is where location data gets really interesting. And now it's interesting to look at how can we detect those things. But before we come to that, I want to really emphasize one part we are doing on our end, and that's the cleaning and pre-processing. If you work with location data, you cannot just aggregate the data. Because if you do so, it looks like this. You have a data which is kind of messy. It suddenly drops and it increases because of technical issues. Sometimes it drops because of behavior, like here, pandemic. It is different for DC than for New York over here. So it is, you cannot just go ahead with the location data. You should really make sure that you put some effort into supply correction, or you buy your data from a partner who takes care of that for you. But after you solve that, or you have the correct data, you can ask kind of, how can we help Walgreens in terms of the potential store? So let's start very simple, but now it gets interesting actually. So we can take the brand average of Walgreens in the US. We can look into that and basically see like how Walgreens behaved over some time when COVID-19 happened, how it recovered here, so that is Christmas, and then how it recovered afterwards in the last quarter, especially where it went back to the brand average before the pandemic. And you could basically look for outliers. Which venues of Walgreens in the US are not showing the same trend of recovery? That's the very first step. You get a lot of venues suddenly which are not correlating and who do not show this recovery effect. That's the first thing. You find outliers of your venues. Then you can plot those on a map, and you basically see that those are located in specific areas. So some areas have a high share of outliers. So, for instance, in San Francisco County, we see more than 50% of those Walgreens venues are actually outliers in the current quarter. So that is interesting. And the question is then, is this a Walgreens effect? But no, it is not, because if we look into, for instance, one of the biggest competitors of Walgreens, CVS, we see actually a very similar pattern, and we don't see in San Francisco County the same effect of the recovery happening. And we looked also in other brands. We looked at Starbucks and so on. And it's really interesting that compared to the brand average in San Francisco County, the recovery doesn't look so well in there. So the question is more not what is happening with Walgreens, it is more what is happening in San Francisco County. And that is where location data can actually shine, because it connects the dots, it gives you additional behavioral insights. With location data, for instance, you can look into migration patterns. So starting from San Francisco County in 2020, where did people move? And what we see is a lot of people left San Francisco County, not so many people came back. So there's a decrease in net flow. And those people left into certain areas. For instance, 15% went into San Mateo counties, 12% into Alameda, and 7% into Contra Costa County. So that is interesting. So we now see certain destinations where people move to from San Francisco County. So would that mean that if you look into those counties, do we see an opposite effect? Do we suddenly see an increase in the visitation or in the potential of those stores? So let's just do that. And here again, in the orange line, you basically see the brand average of Walgreens for the whole US with the Christmas effect and the recovery taking place here. And then at the dark blue line is basically destination areas, the destination counties where people move to from San Francisco County. And this green line over here is basically the origin, the San Francisco County. And what's actually very interesting is that before COVID-19 happened, those destination origin areas were quite similar. But now, afterwards, we basically see a roughly 10 to 12% increase in those destination areas. So for those who like statistics, yes, that also gets statistically significant with the medium to high effects. So that's really interesting to basically see like that there seems to be a connection between the migration of people and the pickup in those stores. So what does that mean for Walgreens? Now you can spin, can go on and go on. You can spin the story here, right? So let's look into the catchment area. So where do people come from when they're visiting a Walgreens store in San Francisco County versus in the surrounding counties where people are moving to? And you basically see that the catchment areas is of course different because there are different counties. But that also means that in terms of marketing efforts and other efforts to target your customers, you can rethink here and put maybe more intention into those surrounding areas. It also means that people in San Francisco County are more likely to go to the store by foot versus in those surrounding counties, it's more likely they take the car. So also the behavior changes, how people are reaching the stores, what the behavior of the customers of Walgreens is, and also visitation length is decreasing because of COVID. You can look into those things like more efficient shopping behavior. So the point I want to make here is that location data actually gives additional insights. It can describe the potential value of a store. It's not just the cash flow. It gives kind of like the potential of possible customers in the future. And if you're using additional metrics coming from other sources, but also from location data, you can actually have a way bigger picture and you get additional information, what actually is causing your indexes or what is happening in your stores, and also how you can change the potential of your stores. So in the retail industry, if you're interested in site selection, in competitiveness, in all the other things which are interested for that area, don't just rely on cash flow, demography, surrounding points, your internal metrics. Also think about how location data can help you because it gives those additional insights. I really like to thank the whole Unacast company, and especially I'd like to thank my team, which is working on this data day and night almost. So we are very passionate about our data. And yeah, that is basically it. So thank you for your attention.
Thank you so much, Michael. I think we have a question on Twitter around different countries, and so obviously the example focuses on Walgreens in the US. How much work have you been doing in different countries to understand human mobility in the context of different lockdown restrictions in different countries?
Yeah, so that mostly happened with our social distancing score. So basically, we, in terms of social distancing, we looked internationally into different countries and also provinces. With other products, like for instance, today I showed more about basically our venue data package, which is more related to venues, brands, retail, and so on. We are focusing mostly on the US right now, so there we did less in other countries.
And in terms of looking at the mobility data in relation to how vaccination rollouts going in different countries, have you started to do anything along those lines, or any of your customers are starting to do that?
Yeah, so of course I cannot talk about too much our customers, but there are a lot of, we have a data for good programs. So I know that actually certain groups at the universities, some universities are looking into that. So that is, it's beyond our scope right now, but we really like that people are actually using our data to look exactly into that.
Awesome. I've got a couple of questions here in the chat. So Wendy Keys would like to know, how do you distinguish between a visitor and a customer from the data?
Yeah, so that is very, very hard. So in the presentation I made today, so I only wanted to show that there is a difference when you have the customer based on credit card. So we did not do this distinction based on those dots, just to be very clear here. That was more an deductive example to show how the data is differently. So just based on the location data itself, you actually cannot do that right away. But there are metrics which are actually correlating with it. So just the visitation to a store does not have the best correlation with actually the cash flow of the store, right? Because there are so many other factors. But for instance, the time spent in a store, or if you do the cross visitation, so basically you look into the people who go to this store, but also to the competitive stores of the same industry code and look into those visitation length, then you get way better correlations if you lay over credit card data. So that still you cannot identify the individual, and this is also something we don't want to do. But in a statistical sense, you can approximate it.
Of course. Okay. We've got time for one last question before we go into the networking break. So Jacob John has asked on the chat, how do you figure out what the outliers in the data were? And is there an automated way to do that?
Yeah, so the one I showed today is actually automated. I just picked 3 venues because there were too many and the data gets messy, right, to show too much. But it was actually super simple. So in for this presentation, I just calculated basically the correlation between the brand average and each individual venue for Q1 2021. And basically looked into venues which have a low versus a high correlation. So basically picking out those with a low correlation or close to 0 specifically here. And so that could be completely automatized, but that's an extremely simplified approach just to show how easy it is to work with that. There are way better ways, actually, if you spend more time on it, to do outlier detection based on principal component analysis and so forth. So unsupervised machine learning gives, I would say, better results, but this is quick.
Awesome. Great. Well, thank you so much for your answers. If anybody